Right now, the Crab Nebula is still firing gamma rays so powerful they shatter every known law of physics, and NASA has no way to stop it, and no explanation for why it keeps happening. The smartest astrophysicists at Harvard, at Caltech, at the Fermi Science Center have been watching it unfold in real time. And what they found buried inside the data is the part they are afraid to say out loud. 6,500 light-years from here, in the constellation Taurus, there is a cloud of superheated gas and shredded stellar material 11 light-years wide. It is expanding, right now, at 1,500 kilometers per second. We have a name for it, the Crab Nebula, and we have been watching it for almost 1,000 years. In the summer of 1054, Chinese astronomers recorded a new star so bright it was visible in full daylight. For 23 days, it outshone every other star in the sky. Arab scholars documented it. Native American cultures etched its shape into canyon walls. That light was the death of a massive star, a supernova so violent it left behind a spinning neutron star the size of a city, rotating 30 times every single second. We call it the Crab pulsar. For decades, it was the standard candle of high-energy astrophysics. The unit scientists use to measure X-ray brightness is literally named after it. If you want to calibrate a space telescope, you point it at the crab. We thought we understood it completely. We were wrong. In 2011, NASA's Fermi Gamma Ray Space Telescope detected something that halted the scientific community cold. The Crab Nebula had flared, not dimmed, not shifted. Flared, erupting in gamma radiation 30 times brighter than anything ever recorded from it before. The burst lasted days, and in the weeks that followed, it happened again. That alone would have been extraordinary, but here is the part that changes everything. The energy released in those flares exceeded something called the synchrotron burn-off limit. That is the absolute theoretical ceiling on how much energy a charged particle can radiate before physics itself shuts it down. The Crab Nebula punched straight through it, like the limit wasn't there at all. Physicists don't use the word impossible lightly. But that is the word they used. Not unlikely, not surprising, impossible. The model every high-energy astrophysicist had built their career on had been violated, in real time, in front of their instruments. The obvious move was to find the measurement error, recalibrate, adjust the numbers and move on, except they couldn't find one. Multiple independent observatories confirmed it. The European Space Agency's Integral satellite saw it. The Agile satellite in Italy saw it. Teams at Caltech, MIT, and the Max Planck Institute analyzed the data independently and reached the same verdict. The Crab Nebula was generating energy that the laws of physics said it could not generate. The leading hypothesis, magnetic reconnection, where tangled magnetic field lines snap and release energy, does not produce anywhere near enough power. Particle acceleration models collapse under the numbers. Every conventional framework fails. But that's not even the part that worries them. Here is the strange part. Here is what should keep you up at night. The Crab Nebula is not some distant, exotic anomaly we stumbled across. It is the most studied, most observed, most calibrated high-energy object in the known universe. We have been pointing instruments at it for over 60 years. We built the entire measurement system of X-ray astrophysics around the assumption that we understood it. Every gamma-ray detector, every cosmic ray observatory, every space telescope ever launched has been calibrated against the crab. It is not just a mystery. It is the ruler we use to measure everything else in the high-energy sky. And the ruler is broken, which means every measurement we have ever taken, every model, every calibrated reading, every confirmed law was anchored to an object that was secretly doing something impossible the entire time. The flares have continued. Smaller events in 2013. Activity flagged again as recently as 2023. Each one reconfirming the same verdict. The synchrotron limit does not apply here. Some process is accelerating particles inside that nebula beyond what current physics allows, and no one has identified what it is. There are theories, plasma instabilities, unknown magnetic structures, physics operating at scales we have never directly observed, but none of them have been proven. None of them have been confirmed. The Crab Nebula is still out there right now, still doing it, and the most advanced instruments humanity has ever built have not found the answer. This matters far beyond one nebula. The Crab was our anchor, our reference point, the thing we trusted most. If our most reliable object in the high-energy sky has been quietly breaking physics, then every equation built on that foundation has to be reconsidered. Every measurement that relied on it, every conclusion drawn from it. Not some of them, all of them. We may have been measuring the universe with a broken instrument for 60 years without ever knowing it. So here is the question no press release will answer. If the most studied object in the sky has been secretly defying physics the entire time, what other impossible readings did we file away as instrument error and never look at twice? What are we wrong about right now tonight, while every telescope on Earth keeps calibrating to a system that has already failed us?